Question 1 is taken from the A-level PastPaper C2 differentiation topic. A cuboid has a rectangular cross-section where the length of the rectangle is equal to twice its width, x. So x is the width and the length is 2x. The volume of the cuboid is 81 cube centimeter. Now we know that the volume is made up of the area of the base times the height. Show that the total length L of the 12 edges of the cuboid is given by this formula or this expression. Let us just see why they are 12 edges. So if you want to draw the cuboid again, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So L mainly is the perimeter of all the cuboid, of all, the edges, or the sum of the edges of the cuboid. Now we need to start with the given, and the given is the volume. So the volume is 81 cube centimeters. Therefore, if we want to find the volume is equal to, now we have to be careful that this side is not given to us, so we call it y. So we need to find the area of the base, which is this, which is made up of 2x times y, multiplied by the height, which is 2x, which is x. So the volume is equal to 2x squared times y. Now the volume is 81 given to us, therefore 81 is equal to 2x squared y. Now if we look at the given expression for L, it doesn't contain y, so we need to write y as the subject and to write the value for y as an expression or in terms of x. Now in order to find the length, we need to add, let's go back to the figure and count. So we have 1y, 2y, 3, 4y's, so it's 4y plus 1x, 2, 3, 4x, and 1, 2, 3, 4, 2x, so it is 8x. So L is equal to 4, replace y by its value, 81 over 2x squared plus 12x. And from here onwards, we use algebra. So here I factored the 4, because I have 4, 4, and 4. So I factored the 4, and then I added these two up, and then I entered the 4 inside so that I make my algebra easier. You don't really have to use my method, but if you need to take this, or if you need to reach what they want from us, you need to separate these values. So you need to have the x alone, you don't take common denominators, in order to get 12x, which is found here. And then you multiply the 4 times 81, and you have this fraction here, so that you can have the same formula that they want us to find. In part B, use calculus to find the minimum value of L. Therefore, when they want the minimum value, it means we have to derive. So in order to derive, we need to change L into an expression that we can derive. So the x squared, which is in the denominator, you take it to the numerator and you write x to the minus 2. Then you derive, Deriving is multiplying the exponent times the coefficient and then subtracting 1 from the exponent, and this is what we did here. And then we place L prime equals to 0 because they want the minimum value, and then you solve for x cubed. So here you have 12 is equal to 3 to 4x to the minus 3. So this is actually 12 equals to 3 to 4 over x cubed. Cross multiply, you get x cubed equals to 324 over 12. Therefore x cubed is equal to 27. Cube root 27, you get x equals 3. Then they want the value for the minimum of L. So after finding the value of x, where it's minimum, you replace the value of x in this formula. So 12 times 3 plus, let me clean up things here, 162 over 3 squared, and the answer is going to be 54 centimeters. So 54 centimeters is supposedly the minimum value for the length. Justify this by further differentiation. So they want you to justify that this is the minimum. So you derive again, and the second derivative is equal to 972 over x to the 4. When you replace x by 3, you get a positive number. Now by getting a positive number, it means that L for this value is the minimum value for the cuboid.